All right, here we got an intro to Objective 5 for Unit 8. Like it says here, we want to recap the video we just watched and highlight some of the main points. Okay, so hopefully you watched the video with the AP Stats guy explaining radians because, I think he makes it pretty clear. And like he says here, first of all, where does pi come from? We use this thing a lot, especially when we're dealing with circles, but sometimes we forget where it comes from. Well, pi is just the circumference divided by the diameter, which means the diameter goes into the circumference pi times. So, try to imagine that, visualize that. If I took the diameter of some circle, let's say I measured the diameter with a string, so I can take this piece of string, pick it up, and bend it around the circle. How many times could I bend that thing around the circle? Well, I can bend that thing around, one time, two times, and then three times, and then there'd be a little bit of an extra piece here. Okay, and that extra piece is 1.14 or sorry 0.14159 keeps on going, and so this diameter I could be stretched around the circle exactly pi times. So again, it's important here to think of pi as a number. Now I know it's hard to because it goes on forever, but let's think of it as 3.14. So the diameter goes around the circumference 3.14 times, so exactly pi times. Okay, and then we're going to focus more, rather than a whole circle, we're going to focus usually on a half circle. So if I cut the circle in half and I cut the diameter in half, well, then that gives me half of a circle, and it gives me a radius. Okay, so then the radius would be that piece there. Okay, and then how many times does this radius, if I can take this and flex it around the edge of the circle, how many times does it go around the circle? Well, it goes around one time, two times, three times, with a little bit of an extra piece. And that again is 0.14159. So it's exactly pi times. So my radius, this would be a radius, this would be a radius, this would be a radius, and then that's the extra piece that makes it exactly pi. That's how many times my radius can go around a half of a circle. And then a radian is just a degree of measurement, okay, for an angle. And it's how wide we have to open this angle. So again, how big do I make my angle to capture 1 radian? Well, it's however big it would be to capture 1 radius on the edge of my circle. Okay, so that's where a radian comes from, which really makes more sense. I mean, why do we have 360 degrees? That doesn't really make a whole lot of sense. And if I've been told correctly, we literally just have 360 degrees because it's divisible by so many numbers and it works out kind of nice. Okay, we don't have to deal with fractions and that sort of thing very often. Obviously we can have like 11.5 degrees, you can have decimals or fractions, but it's just kind of a nice number. So it's nice that it works out kind of nicely, but it doesn't make a lot of sense. So hopefully this at least makes sense on what a radian is. It's just how far I have to open my angle to capture 1 radius on the edge of my circle, or half circle, or whatever you're dealing with. Okay? All right, so then let's look at a couple angles here. This is going to be probably a multiple video set of notes. It's kind of a long one, but we want to make radians as clear as possible. Okay, so like it says, we want to recap some of the more common angles we've worked with in degrees and identify their equivalent in radians. So in other words, how do we write these angles, which are currently in degrees, in radians? Okay, and it all comes down to one main idea, and that is this: 180 degrees equals pi radians. Okay, so this is the main idea. If you can remember this one thing, then you can figure out all these other angles. Okay, because if we look at our little half circle up here, how far do I have to open up to capture half of the circle? Well, I have to capture 1 radius and 2 radius and 3 radii, and then a little bit more is exactly pi radii. So 180 degrees, half a circle, is pi radians because I capture pi radiuses on the outside of my circle. Okay, and that's what it comes down to. So again, even if that's a little unclear, if you just remember this, 180 degrees is pi radians. So pi is 180. Then we can figure out the rest of these things. Okay? And then really, there's 2 or 3 key angles that we want to kind of memorize if we can. Okay? And it's 30 degrees and 45 degrees, and then, like we just said, 180 degrees. So let's do those first. Okay, so 180 degrees, we just set up here, I know that is pi radians. So if I want to convert 180 degrees to radians, it's just pi. That's how many radians it is. Okay? And then what about 30 degrees and 45 degrees? We'll talk about why those are important in just a second, but what would they be first of all? Okay, well, how does 30 relate to 180? Well, 30 goes into 180 how many times? Well, 6 times. So it's 1/6 of 180. So then in radians, it's going to be 1/6 of pi. And what's 1/6 of pi? So 1/6 times pi is just pi over 6. Okay, so that's 30 degrees. 30 degrees is pi over 6 in radians. What about 45 degrees? Well, how many times does 45 go into 180? Well, it goes in there 4 times. In other words, 45 degrees is 1/4 of 180. So then my answer in radians is going to be 1/4 of pi. So that's pi over 4. Okay. All right, so then this is kind of my key to unlocking all these other angles. And then why are these two important? Well, every other angle on here is just a multiple of either 30 degrees, or 45 degrees. So then the rest of these things should be pretty easy to figure out. First of all, what is 0 degrees? Well, if I open up, if I don't open up at all, I don't capture any radians, 0 degrees is also 0 radians. Okay, so that one's pretty easy. Okay, and we'll just kind of go down the list here and go across. Doesn't matter the order we go, but we'll just kind of start from the top left and go down and then keep working through all these columns. Okay, so what is 90 degrees going to be? Well, I can think of it as, 30 degrees, which is pi over 6, times 3, which would be 3 pi over 6, which reduced to 1/2 of pi. Or I can think of it as 45 times 2, which is pi over 4 times 2, which is going to reduce to pi over 2 again. Or I can think of it as half of 180. So it's just pi over 2, no matter how we look at it. Okay? How about 270? So just kind of find the easiest thing to multiply by. Let's see, 270, that'd be 90 times 3. So then it would be pi over 2 times 3, which is 3 pi over 2. Okay? How about 360? What's the easiest one to work with there? Well, probably 180. 360 is 2 times 180. So then my answer here is going to be 2 times pi, and it's just 2 pi. So a full rotation, the whole circle, instead of 360 degrees, we can call that 2 pi if we're dealing with it in radians. Okay. Next one would be 60 degrees. What's the easiest one to work with there? Well, probably 30 degrees. 60 is 30 times 2. So then my answer in radians is going to be pi over 6 times 2, which would be 2 pi over 6, which we can reduce to pi over 3. Okay. All right, next, how about 120? Okay, well, to get 120, I just got to double 60. So if I double this, I'd get my answer in radians, which would be 2 pi over 3. Okay, next, 135. That's maybe a little bit trickier, but let's see, 135, well, that's just a multiple of 45. 45 times 3 gives me 135. So then 3 times pi over 4 would give me my answer in radians, which would be 3 pi over 4. Okay, so that's my answer in radians. And again, I don't think I said it yet. Why are all these angles significant? Why are we picking these angles to convert to radians? Well, because these are all my angles in the unit circle that are going to give me a reference angle that is either 30 degrees, 45 degrees, or 60 degrees. And those are the angles in our special right triangles. Those are the ones we're going to work with the most. Okay. All right, next, how about 150 degrees? So find a good multiple of that. How about 30 degrees? 30 times 5 gives me 150. So then this times 5 gives me my answer in radians. And then pi over 6 times 5 is just 5 pi over 6. Okay. Next, 210 degrees. Let's see, 210 is just 30 times 7. So then 7 times that gives me my answer in radians. So that'd be 7 pi over 6. Next, 225. Okay, well that's 45 times 5. That one's maybe not as easy to do in your head. But 5 times that is going to give me my answer in radians. So that's going to be 5 pi over 4. Okay, next, 240. Well, how about multiplying 120 times 2? Okay, so double that, we get 4 pi over 3. Okay, next, 300. So again, different ways you can do it. How about, 30 times 10? So multiply this by 10, we get 10 pi over 6, which reduces to 5 pi over 3. Okay. Next, 315. Well, 315 is 45 times 7. So then pi over 4 times 7 gives me my answer in radians, which is just 7 pi over 4. Okay. And then last one here, 330 degrees. Well, that's 30 degrees times 11. So then it would be 11 pi over 6 for that one. Okay. So if you're ever trying to convert something to radians, most important thing to know is that 180 degrees is pi radians. Okay, and then another two good angles to know is 30 degrees and 45 degrees. And you can get those from this. Just think how many times I have to multiply this to get that. Or what I have to divide this by to get that, rather, would be a better way to think of it. But once you have these two angles, well, everything else on this page is just a multiple of one of these two angles. Okay? And you don't always have to multiply these two angles. Multiply whichever one you think is easiest, depending on what you already have. Okay? All right. Let's do a few examples from the next page. We'll skip these ones at the bottom. We have some similar examples. We'll skip these. We have some similar examples on our next page, and then we'll probably cut the video into two parts. But first, let's do a couple of these examples. Okay, so now we're getting to the actual notes here. Well, the rest of those notes too. Anyways, like it says here, we're going to now redo the ideas that we learned while in degrees, only this time in radians. So we're going to be doing the same type of problems we've been doing the last couple sections, but now we're going to be measuring everything in radians instead of degrees. And again, the key idea is that half a rotation, which means half of a circle, is pi radians. Okay, which would make the full circle, well, double that and double that, we get 2 pi radians. Okay, again, it's probably better to focus on the fact that half a circle is pi radians, but it's true that also a full circle is 2 pi radians. Okay, let's do some things that we're well acquainted with by now. We want to sketch each angle in standard position, identify the quadrant for the terminating ray, and identify the reference angle. But we want to do this all in radians this time. Okay, so here our angle is 6 pi over 5. Okay, now then how do we sketch that in radians? Let's zoom in a little bit on this problem. Okay, so 6 pi over 5. How do we draw that terminating ray? Okay, now one thing you can always do, and I wouldn't recommend this, but it is kind of a last resort. Well, what is pi? 180 degrees. So I can plug in 180, multiply by 6, divide by 5, and then that gives me my answer in degrees. But we don't want to work in degrees, we want to keep it in radians. Okay, so then how would I draw this in radians? Well, the important thing to remember is that half a circle, so here's 0 degrees, half a circle, 180 degrees would be here. So then this is 180 degrees, which I'm going to write as pi radians. Okay, but since our angle has a denominator of 5, well, let's write 1 pi with the denominator of 5. And I can write that as long as it's 5 pi over 5. Okay, so whatever your denominator is, just put that in the numerator and the denominator, because now I have 1 pi here. Okay, but now it's got the denominator that I want. Okay, let's see, if I cut that in half, this is 180 degrees. If I cut that in half, 90 degrees, well, what would that be in radians? Well, half of this thing would be, this isn't how we normally want to write it, but we can say this is 2.5 pi over 5, just so I'm keeping that same denominator. So every 90 degrees is 2.5 pi over 5. Okay, so this gives me 2.5 pi over 5, 5 pi over 5. This would be 7.5 pi over 5. And then this would be, if I wanted to label it, it could be either 0 pi, or if I double this, I get 10 pi over 5, which gives me 2 pi. Yeah, that's one full rotation. Okay, so this is one way that you can label your axes. And then now I can draw my angle. Where does 6 pi over 5, where is that going to land? Okay, so I need to rotate, let's say I need to rotate past the 2.5, a little bit past the 5 pi, and then my terminating ray would be somewhere right about here, between 5 and 7.5, because we want to get 6 pi over 5. Okay, so then there's my terminating ray. That is in quadrant 3. And then what is our reference angle? Okay, well, I went, from 0 degrees, I went 2.5 pi over 5 to 5 pi over 5, and we kept going to 6 pi over 5. So then how far past 5 pi over 5 did we go? Well, 1 pi over 5, because we went from 5 pi over 5 to 6 pi over 5. So then my reference angle is going to be 1 pi over 5. So I have a pi over 5 degree. Well, not degree, and it's not degrees because it's radians, but my reference angle is pi over 5. Okay, and again, we can get that answer in degrees if we wanted to convert it to degrees. Again, it's easy to convert it to degrees. Just stick in pi is 180. Okay, and then we'll talk later in a different section about how to convert from degrees to radians. That's a little bit different. Okay, but anyways, here's the first one. We're in quadrant 3, and there's our reference angle in radians. Okay. Let's do the next one. I'll alternate colors so we can tell these problems apart here. We'll do maybe 2 more here, and then we'll take a break and we'll split up the videos a bit. All right, next, how am I going to label my axes? That's the first thing I want to do. Okay, well, remember, 180 degrees is pi radians. So this is pi, but I want to write it with a denominator of 9. Well, I can do that as long as I put 9 pi over 9, because then it's still just 1 pi. Okay, so we got 9 pi over 9. So then half of that would be 4.5 pi over 9. And then basically every 90 degrees is 4.5 pi over 9. So keep adding 4.5 to the tops here, and we can label it all the way around if we want to. But we don't really have to, because I can see that, well, 5 pi over 9, well, yeah, that's going to be between 4.5 pi over 9 and 9 pi over 9. Okay? It's going to be just a little bit past 4.5 pi over 9. So my terminating ray would be somewhere about like that. Okay? Well, that is in quadrant 2. And then, well, what is my reference angle? Okay, so this is 5 pi over 9. How much further would I have to go to get to 9 pi over 9? Well, we'd have to go another 4 pi over 9. And apparently I'm writing in black now. And that is my reference angle. Okay, so again, I kind of fall back. Sure, we can convert it to degrees, but then it's going to be hard to get my reference angle in radians, which they're going to want sometimes. Okay, all right, let's do one more, and then I think we'll maybe take a break and split up the videos. Okay, next we got 23 pi over 10. Switch back to blue here. Okay, so again, to label my axes, well, remember, 180 degrees is pi radians, but I want to write pi radians with a denominator of 10, but I still want it to equal 1 pi, so then that would be 10 pi over 10. This one's nicer. There's no decimals this time. Half of this would be 5 pi over 10. And don't worry about reducing it, because that'll just make it harder to find this piece here. So every 90 degrees is 5 pi over 10, so add 5 pi over 10 to that. We get 15 pi over 10 here. And then this would be 20 pi over 10. And then let's see, they want us to find 23 pi over 10. Now here we got to do a little visualizing, because we already labeled this like that. But if we wanted to rotate, how far around would we have to rotate to get to 23 pi over 10? Let's see, this would be 5 pi over 10, 10 pi over 10, 15 pi over 10, 20 pi over 10, and then if I went all the way to my next y-axis, that'd be 25 pi over 10, so we want to stop a little bit short of that, maybe right about there. And then so my terminating ray is going to be in quadrant 1. Okay, and then let's see, we went all the way to 20 pi over 10, then how far past that did we go to get to 23 pi over 10? Well, we went another 3 pi over 10. So then I have a 3 pi over 10 reference angle. Okay? All right, and then we'll stop there. We'll pick up the video on the next problem. Let's just pause for now.